Good afternoon. So I'm Munia, architect, and urban and PhD in urban planning from Architecture School of Paris Val de Seine and member of CRH Habitat Research Center. I must thank you for giving me the opportunity to present some of my research findings about Mozambique habitat in this session. I would like to apologize for my English, and I thank Dr. Naima Benkari for her help to translate my French text. So my talk is about vernacular habitat with the shape characteristic and the uses. We will see in the example of Mozambique dwelling how the thermal comfort depend first on architecture, construction material use, the layout of different spaces, and considerate prevailing winds and temperature variations. Then through an adaptive use and way of living at the scale of a dwelling and oasis. So through two practices, daily nomadism between the different levels of housing and a seasonal migration between the habitat of the Qsar, which called Tadart, and that of the palm grove, which called Akham, and occupied over the period that traditionally ranged from May to October, according to the work of the date palm from May to the date harvest. So the Mzab Valley is located 600 kilometers south of Algiers, the capital of Algeria. It's an rocky site with Saharan climate, with very hot summer and very important difference diurnal and nocturnal temperature and very cold winter. Rainfall in the Mzab Valley is low and irregular, but can still lead to flooding. Thank you. Thank you. The 5 Saharan oases of Mzab Valley was founded between the 11th and 14th century, and they are listed as UNESCO World Heritage since 1982. As we can see, the Qsur and their palm groves are located along the Wadi Mzab, and into two confluences. At the beginning of 20th century, the oasis had nearly 2,000 inhabitants. Nowadays, it constitutes an oasis town, about 200,000 inhabitants, which makes the urban character with the oasis specificity. Next slide, please. The oases have the same principle of implantation. The Qsar is always located on a rocky eminence to stay safe from floods. Then below, the palm grove grows on the bed of the Wadi, where it is easier to dig wells and develop agriculture. The vernacular house typologies that will be presented in this talk no longer exist in their integrity today. It is for this reason that we mainly rely on restitution of works, particularly abundant in the first half of 20th century. In addition, use the information and description collected through the interviews and narratives of people who remember this former Mzab, which still remain very present in their speech. Next slide, please. So the Tadart are mainly built in stone and timshamt. Timshamt is a local mortar used for binding and as plaster. The roof are made of a structure of palm trunks with earth, filled with earth, then covered with timshamt, this local plaster, kind of local plaster. The house spaces are organized in 3 levels and connected by 2 staircases. The ground floor is composed of different spaces which are organized around a central room, which called the patio, or وسط الدار, the center of the house. This central room on ground floor has an extremely important role in temperature regulation. In fact, with the front door, it creates a dynamic airflow which contributes to the ventilation of the ground floor. The central room is also the source of natural lighting in the ground floor through its zenithal opening, which called shebek. So around this patio, the central spaces are organized: the women lounge, reception area for men, the bedrooms, kitchen, and a dry toilet. So it's the central spaces, which all these spaces are organized around. The upper floor, it's semi-covered and partially built, and it's composed of the same spaces. So we find bedroom, small storage room, dry toilet, also shower area, and kitchen area too. So these spaces are organized about the shebek, so the zenithal opening of the ground floor, and it's superposed on the spaces are organized around these spaces. In addition to the floor terrace, there is a second terrace which overlooks the built part of the floor, and which is called a large terrace, very popular for summer sleep and wood storage in winter. Next, yeah, please, thank you. So the Mozabit dwelling, whether located in the Ksar or in the palm grove, is characterized by a way of living based on the daily migration or move between different floors, very interesting to observe. This temporal adaptation to the climate by means of inhabiting is very common in many hot countries, but very characteristic in the Mozabit oasis compared to the other Algerian Saharan oases, which are composed by two entities. So the classical definition is that oasis is aksar for houses and palm grove for the agriculture, but without dwellings. So the duplication, thank you. So the duplication of certain spaces from the ground floor to the second floor, like kitchen, toilet, and other rooms, does not mean that it is a question of two separate apartments occupied separately, permanently, and independently from one another. These are all the spaces in the home that are used at specific times of the day, depending on the alternation between day and night and according to the seasons. Some are versatile and their uses change according to the movement of the sun rays. So during the winter, the sun is 3508 degrees above the horizon. So during the day, the sun is low and the ground floor is very dimly lit and cold. The stone walls allow the heat stored up during the day to escape during the night. In contrast, the floor of the southeast facing upstairs portico is in full sun and at the same time wards the ceilings of the rooms below. These orientations also make it possible to be sheltered from the prevailing northwesterly winter winds. It is therefore on this floor that daytime activities take place. During the season, the loom, as we can see on this picture, during the season, the loom is installed upstairs in the icomar, also the portico, which is situated in the upper floor. At night, the opening of the patio, the shebek, and the doors are covered with rugs to increase the thermal insulation of the room, and the activities move to the ground floor, which has stored the heat in the thickness of its wall during the day. So during the summer, it's the opposite. The inclination of sunrise is over 80 degrees, and habitants move in their house following a movement that is opposite to the one they follow during the winter. So during the day, it starts to get hot since sunrise. Therefore, daytime activities take place in the ground floor, which after releasing all night long, the heat stored during the day is cool and sheltered from the sun. In summer, the loom is installed in the ground floor. In the tahja, tahja is an intermediate space between the door, the entrance, and the patio. During the day, during this season, during summer, the loom is installed in tahja or in tisa-free, so woman lounge, or in the patio, to make advantage for light and freshness predominant in these spaces. The woman's lounge, tisa-free, is below the ikomar portico, and since the sun is high in summer season, the ikomar is in shade and protect the ceiling of tisa-free in the middle of the day when the sun is at its peak. The patio opening is covered with mat and palm moistened to make the airless dry in homes with a cellar. That later is very popular for naps, since they're in important temperature difference of about 10 degrees. During the summer evening at night, all activities take place on the floor between portico and the terrace, the ground floor becoming uncomfortable due to the accumulation of heat absorbed through the day. The large terrace, which overlooks the covered part of the first floor, is mainly used for summer sleep. Then I will present at this point the second type of Mozabit dwelling, which is akham. Akham is the term used to design this second habitat. It's established in the loose built fabric in the oasis with a garden. It is occupied mainly in summer. This duplication of the habitat is also the result of seasonal. It's the result of seasonal migration to the palm grove to stay in palm grove, which listed several months, and it was intended to carry out agricultural work, mainly those of the date palm. At the same time, it was meant as the desire to settle in the palm grove to escape the heat of the Qasr, which lacks vegetation and scarces water resources. Newer than the Tadar, the second type of Mozabit houses is a
if you can wrap up, please.
Okay.
In half minutes.
Just one point, and I will say my conclusion. So just to say that in Akham we have the same materials built, but more sun-dried earth bricks. And for the organization, we find in the Akham the same principle of vertical daily nomadism, like in Tadart. However, the garden added an additional dimension to this move, because if in the Qasr terrace is only spaces allowing to be outside, the garden of the palm grove is the preferred places during the vacation. It helped create a microclimate and humidify the air. So for my conclusion, I just need to say that it's very important to not to imitate the tradition, but learn from tradition. And the objective of my talk is to show how the question of the thermal comfort can also be taken care of by inhabitant practice and simple element. Public and heritage policies must take into account local and specific mode of accommodation. For example, the creation of parks and public garden in line with urban development. Today, the oasis town is expanding, but without thinking about extension of palm groves or parks. In the Saharan towns, the outdoor spaces is a part of residential culture that architect and urban planner must take into account. Thank you for your attention.
Thank you very much, Monia. Thank you for this fascinating presentation. And I will stop sharing and invite directly Jessica Fernandez for her presentation, methodology for the study of the outdoor environment, energy consumption, and resilience of heritage buildings. This is a common paper between Jessica Fernandez Aguilera, Angela Rosa, and Samuel Dominguez.
Hello, good afternoon. This is Samuel Dominguez. Actually, Angela Rosa is the person who is going to present the paper.
Yes. Can you hear me?
Yes, we can hear you.
Okay.
Please go ahead.
Can you hear my presentation?
We don't see it. Yes, it is there. Yeah, go ahead.
Yes. I will be start. Good afternoon. My name is Angela Rosa Garcia. Next, I will present the research work entitled Methodology for the Study of the Indoor Environment, Energy Consumption, and Resilience of Heritage Buildings, a part of my future doctoral thesis. Historic heritage buildings play a very important role in modern societies as they are a way of keeping their identity safe for future generations. It is so much that its conservation becomes a challenge to ensure cultural diversity in a world in constant change. However, they are also an area where the high level of energy inefficiency in their use contribute to a large amount of greenhouse gas emissions. Currently, there is growing interest in reducing these emissions required by both European directives and international agreements, which oblige the improvement of the performance of historic buildings to play an important role in mitigating climate change. Energy rehabilitation has been one of the priorities of the European Union since the signing of the Untitled Chapter in 2007. The enhancement and sustainable management of historic centers is a relevant issue for the cultural identity and heritage of European cities. A rational strategy to preserve the center must be considered both energy and environmental modernization. For this reason, an integrated method of energy and environmental analysis specifically dedicated to the rehabilitation of historic buildings, risk management, and maintenance review is necessary. If we add to this the current global epidemic crisis, with its consequent and probable health emergency, the environmental quality inside the buildings become a very critical point with regard to the future of today's society. The problem is that buildings with these characteristics are excluded from renovation activities, and the balance between historical values and environmental sustainability has not been found. However, energy efficiency and the modernization process represent a form of protection of the historic building and not a change in its original material consistency, something that could provide an effective strategy to protect cultural heritage by reducing cost operation and improvement of environmental quality. We find ourselves in a future uncertainty with regard to environmental quality and health inside spaces, which commits to us to the generation healthy environment and to overcome all kinds prejudices between environmental updating and heritage building because they play an important role in reducing global energy use and CO2 emissions. For this reason, it is necessary to understand the processes of adaptation and evolution of the historicity in order to design strategies and actions that make the conservation and valorization of heritage compatible with the improvement in the quality of life of its inhabitants, allowing the conservation of the city's sustainable history. It is therefore necessary to carry out a holistic approach to improve and ensure environmental condition and conservation, while optimizing its energy efficiency, the introduction of its own energy generation, and in short, reducing its ecological footprint, allowing a sustainable exploitation of the stock building resources. The resource question is, it is possible to design a set of operational strategies of the interior environment of the heritage building within a context of limited energy that guarantees the well-being and health of the user of the building. In other countries, intervention or study have been carried out on the energy efficiency of heritage building. This is the case of the projects such as 3 Cult, in which passive and active solutions for energy conservation and modernization are evaluated in order to generalize this and identify replicable factors where possible. Brenner Path 2 is another project in which the establishment of a European pre-normative is intended for the energy rehabilitation of heritage building for a public or private use. Serrano et al. Propose a digital model obtaining as result the energy report for the rehabilitation of the building. This brought together a series of CATE performance indicators, identification and evaluation of energy saving measures. Environmental control intervention or studies have also carried out in heritage building. Climate for culture uses a simulation and modeling tools to predict the influence of changing outdoor weather on the microclimate in historic building up to 2100, and thus assess the damage of these future microclimates to our collection in various climate zones. Likewise, Jimenez Torrecillas et al. Emphasizes the importance of leaning on the complexity of achieving adequate comfort historic building due to the presence of decorated surface or high artistic value that not allow an intervention on technical elements. Orwarin is in charge of improving indoor air quality through ventilation, indoor air management, the use of low emissions material and products, and the possibility for occupants to control conditions of comfort. The methodology proposed in this research to provide a solution to this problem was made up in 6 phases. In phase 1, selection of the study sample, a total of 8 heritage buildings have been selected that are owned by the Seville City Council and that date between the 13th and 20th centuries. They make up the study sample A. In the figure, you can see the location of each of them. From this initial sample, between 8 and 10 statistically representative buildings will be chosen from the subgroup created for the environmental and energy characterization, which will make up study sample B. In phase 2, the constructive and spatial characterization of each of the building in study sample A will be carried out, which will allow a first classification. A series of files will be generated like the one shown, which include information on each location, year construction, use, construction data, surface, etc. Phase 3, characterization of environmental condition and energy consumption, is developed on the study sample B. It will consist of in situ measurements of the interior environmental condition and energy consumption. Indoor environmental monitoring will be continuous for a period of 15 days in winter, summer, and intermediate season. Measurements will be recorded every 10 minutes, creating a database with current status. The external environmental conditions will be obtained by means of an external station that will be contrasted with the data of the National Meteorological Agency of Spain. Phase 4 will consist of simulation of the evolution of climate change. They will also be carried out in study sample B. The evolution of thermal conditions inside building will be studied with design builder program in the current state and other conditions of future climate change. Phase 5, generation of a database, will result from the compilation of data from the previous phases, generating an open database that can be consulted by the agents in charge of carrying out the rehabilitation or adaptation work of these buildings through the GIS tool. In phase 6, the result obtained in the different parameters studied in the buildings will be analyzed. For this, the database will be treated with the statistical program SPSS and StatGraphic to find correlation between different variables. The following variables will be analyzed: hydrothermal benefits, environmental quality benefits, lining condition and energy consumption, consistency of systems, environmental risk. And finally, once the analysis of the interested monitoring and simulation parameter has been carried out, a classification will be made that allows the comparison and extrapolation of data in buildings with similar characteristics. On this slide, we can observe the first result through the constructive and spatial characterization. Cataloging criteria had been obtained initially based on the chronological time of construction, its morphology, and its current use. In this first analysis, chronological characterization, it has been tried to know the time in which the patrimonial building began to be built, establishing historical relationships. In these figures, you can see the trends of the number of buildings built in the study period and the percentage that each period represents according to the analysis of the sample growth. It can be seen that until the 20th century, there was a specific construction trend. It started slowly and intermittently, and it was not overcrowded. They are values between 1 and 8% of the study sample, although it is worth noting both the 18th and 19th centuries, where an increase in heritage building is observed in both periods. However, the massive construction of the 20th century is striking, comprising more than half the percentage of the sample, specifically 62%. This period coincides with the arrival of the 29 Expo in Seville, and it has been seen the rate of production of buildings of the caliber progressively accelerates, and this period arrives. It can also be observed that in the period after the Expo, a production stage began with a decreasing rate, generating a strike from the 1970s. However, in 1990, we began to see an increase in the production of the building avant patrimonial, which could coincide with the Expo 92 in Seville. A morphological characterization process has also been carried out, being specifically relevant to define a possible use and typology. In the figure, we can see how, as the study period progresses, more buildings with a smaller surface are being built, between 500 and 3,000 square meters. However, you can see how in each area, certain buildings stand out, opting for more emblematic and representative built surfaces, reaching 8,000 square meters. Although in the 20th century, where it has been found that there is a greater construction of building of this characteristic, it is worth noting the heterogeneity of surfaces that exist. Finally, a utilitarian characterization process is carried out, observing that three main uses prevail: administrative, cultural, and uses. A large part of this building objects have been rendered useless due to their environmental conditions, since they do not provide the condition minimum comfort to users, or in the same way, its structural and constructive conditions do not allow it. For this reason, it can be observed that despite the fact that most of them present in excellent condition, they are destined to serve as educational buildings, specifically and to a lesser extent for educational, sociocultural, or creative industry use. As conclusions, this work includes a first approach to the application of the proposed methodology, which includes some of the fundamental characteristics of the building that make up this period, aiming the complete cataloging, both spatial and constructive, of the building stock. With the characterization process carried out on the set of heritage building study, several aspects can be concluded. First of all, in terms of the construction of building, the trend of slow and intermittent production has been verified until the 20th century. However, the 18th and 19th centuries stood out, experiencing a growing increase in both periods. Starting in the 20th century, more than half the percentage of the sample was built, specifically 62%, progressively accelerating the rate of production in this period. Second, the growth
Maria Rosa,
reached.
please, you have a couple of minutes to finish.
Yes. Second,
not a couple of minutes even, 1 minute.
Second, the growth reached a significant period around 1929, coinciding with the influence of the arrival of Expo in Seville. On the other hand, the build surfaces are smaller as the study period progresses. However, from the 20th century on, there is considerable heterogeneity in terms of surfaces. Finally, according to the utilitarian characterization, it has been found that a large part of buildings of the stock study are not currently in use due to their comfort condition, which make the use of the building itself unfeasible. I have included some reference or use for this development of this research. And finally, I would like to thank you for your attention, and I look forward to any questions. Thank you.
Thank you very much, Maria Rosa, and to the team for this very thorough research, and I'm sure it will generate several questions. And now I'd like to invite the next team to start sharing while I'm presenting their topic, and whoever is presenting, please, a short presentation of yourself and your colleagues. So we will be listening to a presentation about a comparison study between the thermal performance of the original and rebuilt vernacular buildings of Dana village in Jordan by Rawana Luzi, Nicholas Karidis, and Maria Elena Nicolopoulou. The floor is yours.
Yes, thank you very much. Can you see the slides, please? Let me know if you can see it.
Yes, it's very clear.
Thank you very much. Good afternoon, everybody. This is Rowan Ndozi, a PhD student at the University of Kent. Today, I'm presenting a comparison study between the thermal performance of the original and rebuilt vernacular buildings of Dana village in Jordan. This study provides a good opportunity to understand the impact of new forms, construction materials, and opening sizes on the thermal performance of vernacular buildings. Dana village in Jordan, which was built between the 1890s and 1930s, has a cold climate in winter, reaching its minimum in January, and temperate to warm climate in summer, reaching its maximum in August. Dana was formed of single-story buildings with flat roofs. It looks like a one cohesive unit due to the organization of contiguous buildings in clusters being one of the main characteristics of the village. By the 1996, the village was almost abandoned and most of its buildings turned into ruins after the local community started to move out in the 1960s, looking for better services and job opportunities. Therefore, the Royal Society for the Conservation of Nature launched a rehabilitation project in Dana Village in 2009 to restore the vernacular dwellings to accommodate tourists and visitors by repairing and transforming existing dwellings on the one hand and rebuilding those that have been demolished on the other hand. Currently, the original and rebuilt buildings stand side by side, offering a unique opportunity to compare their performances. Several restoration strategies were implemented, such as the replacement of the original materials and transformation of the building envelope. For instance, as we can see here, the cane and clay roofs were transformed into reinforced concrete roofs, while the timber beams were transformed into reinforced concrete beams. On the other hand, the 60-centimeter original stone masonry walls, which were composed of stone, clay, and straw, were transformed into 30 centimeter into the new 3-centimeter walls composed of stone, hollow cement blocks, and filled with concrete in between. Combined with the enlargement of opening sizes and the addition of lighting shafts and bathrooms, the implementation of these changes affect the indoor thermal conditions that depend mainly on several factors, including the construction materials, opening sizes, thermal mass, and orientation. Here we can see a few examples comparing the original form of the vernacular dwelling, which was composed of a single space. And after the rehabilitation project, we can observe that it's a multi-spaces after the addition of bathrooms and lighting shafts. Therefore, this paper seeks to assess the effectiveness of the restoration strategies by analyzing the thermal performance of both the original and rebuilt vernacular buildings. In other words, it aims to identify which type is more effective in providing thermal comfort in summer and winter, while highlighting the effect of the restoration on the thermal performance. For this purpose, Dana Hotel was considered as a representative case study because it contains both original and rebuilt rooms within its building. The thermal performance of the original and rebuilt rooms was assessed theoretically and practically. A theoretical assessment includes determining the U value of the original and rebuilt building envelopes. The original one is composed mainly of stone, juniper wood, cane, and a mixture of clay and straw. On the other hand, the rebuilt one is built mainly of stone, concrete, hollow concrete block, and cement mortar. The use of new construction materials led to having different thermal properties between the original and the new building envelope. As seen in this chart, the calculated U value highlights that the original walls, floors, and roofs resist thermal transfer more than the rebuilt ones, offering better thermal properties as they have lower U values. On the other hand, to practically assess the thermal performance of the hotel, 10 hotel rooms were monitored for a period of 2 months, August 2019 and January 2020, including 6 original rooms and 4 rebuilt ones. The original part of the hotel is formed of 12 rooms surrounding the central courtyard from 3 sides. Meanwhile, the rebuilt part is formed of 6 in-suite hotel rooms composed of bedroom, bathroom, lighting shaft, and kitchenette. Cinetag loggers were used to record air temperature every 15 minutes, placing at 1.5 meters above the floor level. The collected data was analyzed and compared between the original and rebuilt rooms, demonstrating the variation of the indoor temperatures throughout the day and providing thermal comfort as the criteria of assessment of this study. These criteria of assessment are first analyzed within the original and regal part of Dana Hotel Security. The statistical method is used to analyze the monitored physical variables to assess the thermal performance, illustrating the fluctuation of the recorded data, which is the air temperature throughout the day, from day to day, and from room to room. And for providing thermal comfort, it's investigated through the Adaptive Thermal Comfort Standard, PSEN 15251. Then a comparison study is conducted between the final results of both parts, using it as an evaluation method to assess the transformation of Dana's original vernacular building within the thermal context. Starting with the results, it was observed in the original rooms that the indoor temperature followed the outdoor temperature profile, but with a significant time lag, being always higher in summer. The maximum temperature is always less than the outdoor temperature around noon due to the thermal mass in all spaces except in the kitchen, which is space 6, due to the high internal heat gains from cooking. The high thermal mass of the original masonry thick wall decreases heat transfer to indoor spaces, preventing heat from reaching indoors in the afternoon, which is the hottest part of the day, reaching 56 degrees Celsius, demonstrating a time lag of 14 hours. In comparison, the daily variation is noticeable in some spaces more than others due to different functions and occupancy time. Small variation and less significant fluctuation over the day are noticed in room 1, 3, 4, and 5. This is because the thermal inertia of the thick stone walls and clay roof This is because the thermal inertia of the thick stone walls and clay roof offers small fluctuations in the indoor temperature. The high thermal inertia of the original materials increases their capacity to store heat and then emit it outdoor when the temperature is lower. However, lower indoor temperatures are noticed in room 4 and 5 because their roof is not exposed to the outdoor conditions, having an additional floor above them, as we can see over here. Meanwhile, the roof of room 1 and 3 is exposed to the outdoor conditions and solar radiation, leading to absorb heat and transfer it to indoor spaces. The diurnal swing values at room 2 and 6 are more significant and variable, ranging from 4 to 9 degrees Celsius. For room 6, it has been used as a kitchen. Because it has been used as a kitchen, the excessive indoor temperature that jumps above the outdoor temperature most of the time due to cooking produced heat. Furthermore, the absence of windows raised the indoor temperature, storing the heat indoors without efficient airflow and ventilation. For room 2, it was observed that its roof was replaced with a concrete one, having its roof transformed among the other original spaces created the difference in the thermal performance. The new concrete roof failed to resist heat transfer due to its lower capacity to resist heat transfer than the original clay roof. Therefore, the indoor temperature of room 2 shows more fluctuation compared with the other rooms, reaching higher points, as we can see here with the red lines. A different pattern of variation is noticed in winter. The indoor temperature follows the profile of the outdoor temperature in room 3, being the coldest room among the other original rooms. This is because the sun does not enter this room due to the absence of windows. Moreover, it was not occupied during the winter monitoring period, showing less variation in temperature. Similarly, rooms 6 and 4 were also unoccupied but showed higher temperatures due to reduced heat losses from their roof, which is not exposed to the cold outdoor conditions. On the other hand, the daily variation is more noticeable in room 2, with a diurnal swing ranging between 3 to 8 degrees Celsius. The indoor temperature is most of the time higher than the outdoor temperature, and the difference between them sometimes approaches 12 degrees Celsius when the outdoor temperature is very cold. The indoor temperature reaches its maximum in the afternoon and minimum at midnight. This is because when the outdoor temperature reaches its maximum near noon, the concrete roof of room 2 transfers the absorbed heat to the indoor spaces after a short time due to its lower thermal capacity. As expected, the variation of indoor temperature is influenced by the building envelope and opening sizes and orientation, as well as construction materials. The few and small size of windows protect the indoor spaces from direct solar beams during summer days and offer good ventilation and cooling during summer nights. Meanwhile, these windows allow the sun rays to indoor spaces during winter days due to their lower elevation angle. Moving to the results of the of monitoring the refit rooms, the trend of the indoor and outdoor temperature is different than the original rooms, as the changes of the indoor temperature do not follow the changes of the outdoor temperature in summer. The indoor temperature is higher than the outdoor temperature at night and lower during the day. The fluctuation of the indoor temperature is small and the temperature is consistent. Indeed, the daily variation is hardly noticeable in all spaces despite different occupancy hours. They reach the maximum temperature in the afternoon and the minimum in the morning. The enlargement of windows and the addition of lighting shafts helped in providing cooler conditions. In terms of enlarging the external windows, these windows enhance air movement due to their bigger size. This strategy is efficient as they are northern windows, which do not bring in solar gains. Moreover, the addition of lighting shafts is providing internal windows that enhance the air movement and ventilation for cooling. It's observed that room 8 has slightly colder conditions compared with room 9 and room 10, although they have the same building envelope, opening size, and orientation. This is because room 8 is bigger in size, increasing the heat transfer area in the room. Moreover, room 7 and room 8 have approximately the same area, but room 7 is slightly warmer due to have southwestern windows that bring in solar gains, warming up the indoor spaces in the afternoon. A different pattern is noticed in winter with a wider fluctuation, less affected by changes in the outdoor temperature. The indoor temperature is higher than the outdoor temperature most of the time. The daily variation is noticeable sometimes in some spaces more than others. For instance, the diurnal swing varies from 0 to 8 degrees Celsius, showing small values at room 7 due to non-occupancy status, as we can see here. Meanwhile, the diurnal swing values at room 8, 9, and 10 are bigger and more variable according to their occupancy time. In comparison, the pattern of the indoor temperature variation is different in the original and rebuilt rooms of Dana Hotel. The box plots highlight that in summer, the indoor temperatures are higher in the original rooms compared with the rebuilt ones. Meanwhile, the indoor temperatures are more steady in the rebuilt rooms, showing less variation. The more extreme values are noticed in the original spaces, as we can see in room 2 and 6, showing less variation. Showing more variation. However, they are close to the mean. The temperature are more close to the mean values, to the mean temperature values in the rebuilt rooms. In winter, the indoor temperatures are either similar in both types of rooms or slightly warmer in the rebuilt rooms. The original spaces show different performances as some rooms, such as 4 and 6, show less variation in the indoor temperature compared with the other original spaces, as they were unoccupied at that time. Meanwhile, the other original and rebuilt spaces provide similar variation in the indoor temperature. To discuss
you have 1 minute left.
Okay. To discuss the results, let me go back to these counts. Yeah. The analysis highlights that the performance is greatly affected by materials of the building envelope and opening sizes. Okay, just to summarize the results, along with the thick walls, the addition of lighting shafts and the enlargement of northern windows adapt the rebuilt rooms to the outdoor conditions. As we can see, the lighting shafts over here and here, here and here. The bigger and more windows were used in the rebuilt rooms, enhancing the air movement while preventing solar gains. The orientation of these openings reduced the impact of their size because the direct solar gain is the main contribution affecting the indoor temperature. Therefore, the inward and northern orientation of the windows and lighting shafts of the rebuilt rooms reduced the impact of being more exposed in summer. Moreover, passive cooling strategies such as plants and trees in front of the rebuilt rooms enhance night cool breezes. The adopted changes in the rebuilt rooms work together to adapt the weather as a whole system, including the replacement of the building envelope, the addition of lighting shafts, and the enlargement of windows. Replacing building envelope without increasing the opening sizes would disable the whole system, as observed in room 2. The replacement of the original roof while keeping the original opening sizes failed to adapt the outdoor conditions, providing more variation and indoor temperature. In summary, let me show
one sentence to summarize.
Yes, for each slide, just one sentence. We can see here discussing the thermal comfort in both types of buildings. We can see that desired thermal comfort is achieved in the original rooms in summer, as they lie within the comfort ranges, while all the original rooms show failure in providing thermal comfort in winter. For the rebuilt rooms,
thank you very much. Thank you. Really, I cannot give you more time, so that we try to have a little bit 2 minutes for Q&As. I'm sorry for that.
Yeah.
I'm so sorry for that. And now I'll call Dr. Alia to present her work with Dr. Hanan regarding the Souq Matrah framework for designing livable outdoor spaces. And we will come back if we have time in the Q&A to so that you can finalize what you have to formulate, Rawan. Thank you very much. The panelists can open their cams if they want.
Can you see my screen?
You are from the house, so try to compress as much as you can.
Don't worry, I'll take care of you. So can you see my screen right now?
Yes, yes. It's very clear.
Okay, great. So I'll go ahead and start. So my name is Alia Al-Hashim. I'm an assistant professor at Sultan Qaboos University, Department of Civil and Architectural Engineering. So the paper I'm presenting today is with collaboration with my colleague, Dr. Hanan Al-Khafri, who is also assistant professor here in our department. So the topic for my presentation is Souq Matrah, a framework for designing livable outdoor spaces. So I'm taking Souq Matrah as a case study for analyzing livability in the outdoor spaces. The way that the presentation is structured today, I'll have a small introduction. We'll talk about Souq Matrah's evolution, the urban fabric, then different models. One will be the thermal model, the visual model, and the behavior model, and finally, conclusion and recommendation. So to start with, the streets have been used as a space for engagement in commercial and social recreational activities throughout the years. So livability of street and open spaces is a major consideration for designing sustainable cities. So the livable outdoor spaces encourages dwellers to spend more time outdoors, which is important because of its positive impact on health and well-being. So a healthy community encourages its dwellers to spend more time outdoors. A livable street is defined as a street with the presence of numerous people engaged in a variety of predominantly stationary and sustained activities. These activities most of the times are of social nature. In recent years, privatization of public spaces, shopping malls, corporate plazas have replaced traditional public spaces and the main street. So having the malls have attracted most of the visitors, and this has reduced the traffic that we saw over the years in public streets. Vernacular urban fabric has proven multiple times its efficiency in designing integrated social and socially active, thermally comfortable outdoor space. One of such urban fabric is matrah. It was established at the sea in the 16th century, but until present day, preserve its identity and its importance as an attraction point for both locals and tourists. So even now, with all the malls and with modern spaces and malls, people still choose to go to Matrah Street, and tourists also consider it as one of the most important destinations when they visit Muscat. The aim of this research is to focus of this research is to determine the relationship between the micro-scale physical characteristics and uses and people's pattern of social activity in commercial streets. So linking the human behavior with the physical properties of the street. The underlying object of this study is to investigate the correlation pattern between spatial behavior and physical characteristics of the urban space. Methodology followed in the research is that the open space was analyzed in terms of physical geometry, connectivity, thermal and visual performance. So different models were created for showing the different layers or performance of different aspects. These properties were then overlaid over the spatial use and behavior. Multiple Rhino grasshopper scripts were used to extract urban geometry, connectivity properties, and thermal and visual performance of the urban fabric. So over here, this is just a demonstration of how different types and different layers of an urban property were considered and linked to the human behavior. So before discovery, just to give you an introduction about matrah and matrah souk, before discovery of oil in 1970s, matrah was the center of Omani commerce. It is still considered the largest seaport in the region, consisting of traditional marketplace called a souk matrah and housing communities. Strategically located adjacent to the Harbor Muscat, it witnessed thriving trade in the age of sail. Souk matrah gave way to cosmopolitan society to function and trade, who maintained their culture, habits, and language through the engagement with the local traders. This was the reason why matrah souk thrived in the beginning and is still thriving. The souk still maintains a unique sense of place and a position worth of studying. This sense of space that the souk matrah is providing is one of the key reasons why it is still maintains its identity and maintains its livelihood. Matrah's first graphic representation appears as mature urban settlement, occupying the free flat areas with small percentage of seafront dependence on their urban area. So in the beginning, it was noticed that when the settlement started, it was a bit away from the sea, a bit keeping this cautious space between the sea and the settlement itself. Matrah began to actually grow in 1964, 2 years after the oil was first discovered in the country, and it started booming as one of the ports. By 1974, it was significant. There was a significant perpendicular expansion towards the sea, and notable tendencies to expand towards the inner land, where the topography allowed. So if you see or track the shape of the settlement of Matrah, you would see that the integrity of the overall shape remained. However, it expanded wherever the land allowed it, whether it was in front of the sea, in adjacent to the sea, or towards the topographical area, wherever the land allowed it. Now, souk matrah's current general state is similar to the way it appeared during the 1970s. So if we compare from 1970 up until now, we would say in terms of the fabric itself, it has maintained its integrity or the same shape itself. The most apparent difference in the souk over the time are the changes in land use. So as the years passed, the land use kept on changing, the type of the shops kept on changing. based on the variety of the products that was received from the harbor and the variety of the products that the consumers started preferring more and more. So according to that, the land use kept on changing, and the products sold in these areas kept on changing and adapting over the years. Souk Matrah is an example of pure centrality, as everything connects back to main spine. So there is one main spine that you can see in all of the evolutionary maps that has maintained its integrity and which remain consistent over the years. The souk's operation within its context is much more immediate in geographical and topological terms. So if we just look at the souk in terms of how the fabric is, how the land use subdivided, or how the fabric is subdivided, one distinctive feature of Oriental Islamic towns and cities is the specialized markets where shops selling the same range of goods are grouped together. So the same thing for the Matrah souk. So the shops that sell the same item, which whether it's silver, whether it's gold, whether it's fabric, they are grouped in one area so that the consumer, as he goes, he gets a chance to have a look at all the variety of the goods and to be able to choose from it. Retail and wholesale are separated into two spatially segregated districts. So the retail district is known as small market of Souk al-Saghir, and the large wholesale market is known as Souk al-Kabir, as seen in the map, with both extending along the eastern half of the bay. Within the two souk districts, the shops are set in rows on either side of the alleyway, so the consumer gets the chance to, as he goes on, he's going through a series of choices, a series of shops as he moves along the alleyway. Both districts are separated by natural flood channels. So the main alleyway that you can see in between, or the main pedestrian spine that you can see in between, is also known as Khorbumba, which is the natural flood channel for the seawater. The total pedestrian network is around 6,270 meters in the entire Souk Matrah. And since the souk has been one of the main touristic destinations of Muscat, it explains the large number of souvenirs and antique shop focused along the main spine. However, as the pathways continue further away, the products of the retail units tend towards more regular day-to-day shopping for the residents of the neighborhood areas. Over here in this map, you can see that there are different pedestrian walkways. They change in terms of the width that we will talk about later. So you will see that they change in terms of width and height of these pedestrians. And also you would find that multiple pedestrians, they connect each other in areas known as nodes. These nodes are where multiple pedestrians get together and create a bigger node. Now, coming to the thermal model, urban canyon is a simplified rectangular profile of infinite length. It has been adopted as the basic structural unit for describing a typical urban open space, based on the width, height, orientation, angle, and the shade of the rectangular profile of the urban canyon. The pedestrian network in Souk Matrah can be categorized into 9 types, 8 of which are the pedestrian pathways that we talked about, and the 9th is a node. It is known as the node. So over here on the left-hand side, you can see a diagrammatic or a schematic view of what an urban canyon is and what are the major parameters that define the urban canyon based on which these types were defined. One is the height of the urban canyon, the other is the width, the other is the orientation of the orientation angle, and the 4th is whether or not this urban canyon has the shape. On the right-hand side, you can see all the typologies, their orientation, height over width ratio of the urban canyon, the dimension, and you can see on the map how these types are projected on the pedestrian map that we can see, the connection map that we can see of Souk Matrah. And we can see how the different types manifest within the urban network. Now, continuing on the thermal model, An urban microclimate model is fundamental to the evaluation of outdoor thermal comfort. And the analysis geometry used for the thermal model was the urban canyon that we spoke about in the earliest slide. The unit of measurement chosen was the mean radiant temperature. Now, the mean radiant temperature is a key variable for evaluating outdoor thermal sensation in certain conditions. So it is the mean radiant temperature is used in order to evaluate the thermal comfort instead of just the outdoor temperature. The tool that was used to conduct the thermal model is Rhino Grasshopper with the plugin of a Ladybug. So here you can see in the right-hand side, you can still see the different typologies that we have segregated the urban canyon into. And then next to it, you can see the mean radiant temperature fluctuation throughout the year, 24 hours of the day. And the grayed areas, the dark grayed areas, are the time when the souk is not functioning. So just to bring to your attention, the souk functioning times are from 10 a.m. up until 1 p.m. And then after that, it functions, it closes and it opens again at 4 p.m. and continues up until 10 p.m. So if we compare, as compared to the outdoor mean radiant temperature, the pedestrian network in Souk Matrah provides thermally comfortable environment, especially in two spaces, which are the node and the type number 2 urban canyon, where we can see a significant decrease in terms of the mean radiant temperature. So if we compare it to the outdoor measurement point, we see that the difference in need, or the delta, or the difference in the mean radiant temperature is around 35 degrees Celsius in the summertime. Although the difference is not as much in the winter times, but the environment, the thermally comfortable environment that the pedestrian provides can be seen during the summer and the equinox months. Moving on to the visual model, ISOVIST is defined as the field of view from a specific standpoint, and ISOVIST was the unit of measurement.
You have 1 minute left, Alia.
Okay.
You have 1 minute left.
Okay. So ISOVIST was used as the specific form for analysis. Two types of analysis. One was the total visibility analysis. The second was the complexity analysis. We have two maps which shows how the visual series changes as you move from one point to another in the pedestrian network. And we can see there is a huge difference, a huge variation. So that is why the Matrah is able to provide a unique visual journey, ranging from a very wide seafront area to narrow alleys. Now, Souk Matrah is accessed through the main gates. However, there are multiple access points from the site. The main spine lacks any seating or eating area. This is to keep the shoppers don't give the chance for the shoppers to linger around. So where they actually spend most of their time, the shoppers or the visitors are actually at either the two ends of the souk. They don't spend much time. They in the pedestrian of the souk. They simply pass by and shop. Whereas the parts which provide the seating areas are the front and the sides of the souk, at the edges of the souk. So finally, just to wrap everything up, the spatial correlation patterns, physical characteristics, urban fabric, and behavior can reveal factors influencing the livability of open area. Now, just to move on to the future step instead of going through all of them. Now, the future step for us is to standardize simulation models and apply them on different urban fabrics to be able to correlate the factors with the behavior and be able to predict the performance of future urban designs and not only analyze the ones that we already have. Thank you very much.
Thank you very much, Dr. Alia, for this very interesting presentation and for trying to stick to the time. Now, I have a question to the whole audience. Now we are stepping in the time of the break. And as you can see in the chat, there are very interesting questions. So I would suggest that we go ahead with the questions, and unfortunately for people who prefer to go on break, please, you may do so. There are questions from Professor Susan Turawan, I think. in room 2, was there mechanical cooling in summer and heating in winter?
No, actually, all the original and rebuilt rooms are free
I
running.
forgot just to add something. Please
Yeah.
be as short as possible in your answers.
Yes, it's very short. Actually, I was saying that all the original and rebuilt rooms are free running, having no cooling or heating system or devices, so that we can compare the thermal performance of all rooms.
Thank you very much. There is another question, I skipped it, to Munya from Professor Susan. What is the main directions of the winds in the Mzab, and how is it related to the orientation of the courtyard?
In winter, the dominant wind is from north, but it's come from north, northwest, or west. But the dominant wind is from north, and in the winter, the hot winds, the dominant hot winds, are from south, but they can come from southeast or northeast also. And I think she asked also if the wind come up or down. It's come up the valley.
Okay, and is this the reason why the courtyards are all oriented northeast to southwest?
Yes, it's one reason, but there is other reasons according to the temperatures, because there is the element of wind, but there is also the temperature and the variation temperature between different seasons. It's not only a reason.
Thank you very much. Another question to Rawan from Professor Rijal. Is it better to conduct a regression analysis in between indoor and outdoor air temperature? The indoor temperature is high in summer and low in winter. How about the thermal comfort of the residents?
Yes, actually, for the thermal comfort, unfortunately, I couldn't present the analysis as I had no time to complete my presentation. Yeah, but actually, both the original and rebuilt rooms provide thermal comfort in the summer. However, the rebuilt rooms offer slightly better thermal comfort, avoiding the higher indoor temperatures. On the other hand, in winter, both the original and rebuilt rooms do not provide thermal comfort. This can be explained. Maybe the Royal Society, when they launched the rehabilitation project, they were more concerned about providing thermal comfort in summer because Dana is a summer tourist destination. This is because, and also this is because winter is short in the region, shorter than summer, like maybe 2 to 3 months.
Thank you very much. There is also, I think, a comment or suggestion from Professor Rijal to you, Rawan, and her colleagues. Whether is it interesting to compare the slope indoor-outdoor relation of before and after improvement, and try to compare with other studies too?
Yeah, actually I've done this. I compared it with other studies. You can check it in the paper maybe.
Very good, we will share it.
Yeah.
Okay, I have a couple of questions for Dr. Alia from Professor Elini. She's asking you about the spine, the term spine that she used. Did the built environment expand along the main communication lines dictated by the commercial activities? This is what you call spine.
So the spine is the main pedestrian area that is going through Souk Matrah. So it is the main area, the entrance where you would enter Souk Matrah and you would end your journey at. And in between there are other smaller pedestrian, in terms of important smaller pedestrian network. But this spine is very recognized. So that is why we call it the spine. And then there was another question about the urban canyon also. For that, I would just let you know, to clarify, the urban canyon is the negative part. It is surrounded by the built space. So the urban canyon is actually the open part where is there is no building. So yes, there were urban canyons in the housing areas also, and their categorization can also be within the 9 types that I presented earlier.
Thank you very much, Dr. Alia. I just posted my request in the chat box. If possible, I'd like to ask all of you, please, to open your cameras, if possible, so that we take a collective picture of this session. It was really, really interesting and very inspiring.
Hi, everyone.
Hi, everyone. Thank you for the fascinating presentation. Thank you. I enjoyed it.
Thank you so much. And with this, I will call off this session and allow you a little bit of time to have a break. Thank you so much to the
Thank you very much.
And thank you very much to the audience for these very interesting questions and follow-ups. Hope to see you in other sessions. Bye.
Thank you.
Bye.